Hello, 7th graders, and welcome to Lesson 7.1 on Inequalities. Before we get to inequalities, let's review what we've been working so far in Chapter 6. In Chapter 6, we learned about inverse operations. Inverse operations are what we use to solve for a variable when we're solving an equation. So in this example, we have 3x equals 24. To solve for x, we need to divide by 3 because division is the inverse of multiplication. When we divide both sides by 3, remember both sides balance the equation, super important, we get x equals 8. In the second example, we have z plus 6 equals 4. To undo addition, we need to use the inverse operation, subtraction. Subtract 6 from both sides, and we get z equals -2. All right, now that we've reviewed a little bit, I would like you to try these 3 problems on your own. Pause the video, and then play it back to see if you got them right. All right, in number 1, we need to divide both sides by 9 since it's multiplying. The inverse of multiplication is division. So we get w equals -6. -54 divided by 9 is -6. In the second one, we need to add 12 to both sides, and b equals 15. And in the last one, we need to multiply both sides by 4. So we get n equals -44. All right, we also had a lot of really important vocab so far in Chapter 6. So let's review those. Before we start with inequalities, we're going to use the checked words in this box to fill out these boxes. Okay, so x, any letter representing a number is a variable. And then we have 2, which is just a number. If there's no variables, we call that a constant term. Now we have 3x plus 2. There's no equal sign, but there's both a variable and some numbers, a math sentence. We call that an expression or an algebraic expression. And last but not least, we have an expression with an equal sign and a solution that is called an equation. So a couple other things that aren't reviewed in this box. A coefficient is a number before a variable. So if we have that expression 3x plus 2, 3 is the coefficient. That's this word right here. So 3 is the coefficient. And then both 3x and 2 are terms. These are not like terms because they don't have the same variable, so we can't combine them. We have to leave it as an expression. But terms are separated with addition and subtraction. So if I added on plus 4a, now I have 3 terms. And remember, like terms are terms with the same variable. So if I had 3x plus 2x, those are like terms. I can combine those. 3x plus 2x is 5x. Like terms have the same variable. So when I combine them, I'm adding their coefficients to get the simplified solution. All right, so let's start inequalities, writing and solving one-step inequalities. Before we actually solve any inequalities, we're going to investigate them a little bit first. So you know that when you perform any of the 4 operations, addition, subtraction, multiplication, division, if you do it to both sides of the equation, balancing the equation, the result is true. So in Chapter 6, when we had x plus 2 equals 7, we subtract 2 from both sides, so we just perform subtraction. But to both sides, the result is true, so x equals 5, and then we consider that our solution. So there are no variables in this example, table A, but we're going to see if when we add to both sides, the new inequality is still true. Quick refresher on inequalities. You'll see a table just appeared up here. These are our inequality signs, so we have greater than or equal to, less than, and less than or equal to. It is or equal to if it has the line under it. And then the sign always points to the smaller number and it eats the bigger number. So some of you in elementary school might have had your teachers draw little teeth here and said it ate the bigger number. Or you might have just done like a bird beak and it points to smaller. So however you remember that is fine, but we need to know those 4 signs. Okay, so let's investigate inequalities a little bit. Looking at this table, if we add 3 to both sides of 2 is greater than or equal to -3, so we're going to add 3 to both sides. 2 plus 3 is 5. Keep the sign the same. And -3 plus 3 is 0. Is 5 greater than or equal to 0? I think that is true. All right, so now we're going to add -1 to both sides, or we're going to subtract 1. So let's subtract 1, subtract 1. -1 minus 1 is -2. Keep the sign the same. 6 minus 1 is 5. All right, is -2 less than or equal to 5? I think that is also true. Okay, last one. Now some of you might be looking at this and be like, wait, but 8's not bigger than 10. But remember, when it's negative, the number line flips the opposite direction at 0. So -8 is less negative than -10. So it's actually bigger because it's closer to 0. It's closer to the positive, so it's bigger. All right, so we're going to add -8 to both sides. We're going to subtract 8. -8 minus 8 is -16. -10 minus 8 is -18. And just like our rationale for the first one, -16 is less negative. So it's closer to the positive, so it's bigger than -18. This is still true. All right, so we're going to reflect on this a little bit. When you add the same number to both sides of an inequality, is the inequality still true? Yes. How do we know that? Because you balanced the equation. Balanced equation. Okay, example B, letter B. We're going to experiment with division now. So we have 4 is less than 8. We're going to divide both sides by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Is 1 less than 2? Yes, it is. All right, now I know some of you are getting a little bored with this and want to zoom through, but we're about to come to an important piece of information, so just stick with me, okay? All right, next we're going to divide both sides by 3. 12 divided by 3 is 4. -15 divided by 3 is -5. Yes, 4 is greater than -5. All right, here's our important revelation. Okay, divide both sides by -4. -16 divided by -4 is +4. 12 divided by -4 is -3. Now, if we kept the sign the same, it would be pointing that way. But is 4 less than or equal to -3? And no, it is not. So we are going to write false. And let's see if that's true for another negative. So we're going to divide by -5. And 15 divided by -5 is -3. 5 divided by -5 is -1. I know the number 3 is bigger than the number 1, but these are both negative, and -1 is less negative than -3, so it's closer to 0, so this one is also false. What do you notice about the false ones? The false ones were when we divided by a negative. So let's think, what could we do to those inequalities to make them true? We could flip the sign. We'll come back to this in a couple pages, but remember that when we divided by a negative, it was false. We'll figure out what to do in a minute. Okay, so before we get to that tricky multiplication and division with inequalities, we're going to review with some addition and subtraction. This is the same as when we're solving an equation. So if you look up here, it tells us the addition and subtraction properties of inequalities. You will not need to cite these. Basically what they say is when you add or subtract the same number of both sides of an inequality, the inequality will remain true. So you can add or subtract, and you don't have to do anything with the sign. It's still true. All right, which helps us when we're solving for variables. So if I have x plus 5 is less than negative 12, to solve for x, to get x by itself, I need to subtract 5 from both sides. When I subtract 5 from negative 12, we get negative 17. So my answer was x is less than negative 17. And we haven't went over how to graph these yet. We will do that after we cover the multiplication and division. But concept of this page, you can add or subtract to a variable. Is if you do it to both sides of the inequality is still the same. So we can solve for a variable the same way that we would in an equation if there's only addition and subtraction. All right, so here's one more example up here. We have 8 is less than or equal to y minus 3. We're going to add 3 to both sides, and we get 11 is less than or equal to y. You can rewrite it backwards. So if you read it 11 is less than or equal to y, it's the same thing as reading y is greater than or equal to 11. So then we write it backwards. You graph it with, so notice how it's pointing to the bigger numbers because y is greater than 11. And then the or equal to had a closed circle versus the one on the last page was just less than, so it was an open circle. All right, don't worry about the graphs yet, but I want you guys to see if you can solve these two inequalities for the variables. Pause the video, try them by yourself, check it back to see if you got them right. Go. Okay, so remember when we said we could add or subtract both sides of an inequality and it'll still be true? That's only true for a positive number when we're multiplying and dividing. When we multiply or divide by a negative number, we actually have to flip the sign. We reverse the inequality symbol for it to be true. Why that happens is because if we have a number line of 0, this direction is positive and this direction is negative. And we know that a positive times a negative equals a negative, and a negative times a negative equals a positive. So let's see some examples on the next page. All right, we're going to start with example B so that we can look at this negative stuff. If I have negative 4x is greater than 52, we divide both sides by negative 4, and I get x, and then negative 13. So yx has to be less than negative 13 because we'd think it was greater than. It started with a greater than symbol. But again, I know a negative times a positive equals a negative, and a negative times a negative equals a positive. So if we check the numbers around 13, so I multiply negative 14 by negative 4, and then I get a positive number bigger than 52 because a negative times a negative equals a positive. But if I take a negative number where the number is less than 13 but the negative is greater than 13, like negative 12, that negative times a negative cancels out. 48 is less than 52. So we could use a positive number too. Say, let's try positive 13. Positive 13 by negative 4. So any positive number times negative 4 is going to be negative, which is going to be less than 52. So for negative 4x to be greater than 52, it would have to be a negative number so that the negatives cancel out, and that negative number has to be further from 0 than negative 13. All right, so our answer would be x is less than negative 13. So good thing to write in your notes, flip the sign. So if you go back to the other page, it says it's true for a positive that you can do the same thing to both sides, but when you're dealing with a negative, you have to flip the sign. All right, and I went ahead and added that up here if you want to just copy that into your notes. All right, one more example. Y divided by 3 is greater than or equal to 5. To undo division, we multiply both sides by 3. 5 times 3 is 15, so y is greater than or equal to 15. Because 3 was not negative, we did not multiply or divide by a negative. The sign stays the same. All right, so let's look at some graphs. Let's learn how to graph inequalities. If you have a greater than or a greater than or equal to, like in this example here, the arrow on the number line is going to point to the greater numbers. So if x is greater than the solution, it's going to point to the greater numbers. If x is less than the solution, like in the second example, the arrow on the number line will point to the lesser numbers, to the smaller numbers. If you write the variable first, that inequality sign points in the direction that the graph goes. One more thing. You may have noticed this circle is open, this circle is closed. When an inequality is or equal to, it's closed because it could be equal to that number. It could include that number. If an inequality is not equal to the number, the graph is going to be open because it does not include that number. So in this example up here, x does not include 2, so it's an open circle on 2, pointing to the bigger numbers because it could be anything bigger than 2, but it can't include 2. But then on this bottom one, x is less than or equal to 1, meaning it could include 1, so it's a closed circle on 1, and then points to anything less than 1 because x could also be anything less than 1. All right, one more example for our notes today. We're going to look at a real-world problem. So a marine submersible descends more than 40 feet below sea level. As it descends from sea level, the change in elevation is -5 feet per second. For how many seconds does it descend? Okay, so first we're going to start a plan. To do that, we need to look at our information. We know that they descend more than 40 feet below sea level. Its change is -5 feet per second. So how many seconds does it descend? -5 per second, so we're going to say that's -5 times the variable. We'll just say t for time. So -5 times t, and it has to descend more than 40 feet. But because 40 is represented with a negative, the numbers smaller than -40 are actually going to be further below sea level. So it has to be less than or more negative than -40. So our plan that we're going to solve is -5t is less than -40. So we divide both sides by -5, flip the sign because we divided by a negative, and we get t is greater than 8. All right, I want you guys to pause the video, try this one on your own, and then play it back to see if you got it right. All right, I'm going to go ahead and solve it. Every month, $35 is withdrawn from Tony's savings account to pay for his gym membership. He has enough savings to withdraw no more than $315. For how many months can Tony pay for his own gym membership? Okay, so every month, $35 is withdrawn. He can pay no more than $315. No more than means less than or equal to 315. And it's 35 per month. All right, then we solve for m. Divide both sides by 35. You should get m is less than or equal to 9, which means Tony can pay for his gym membership for no more than 9 months.